Let's take a look at systems of linear equations in two variables. And let me get the pen or the tablet going. Excuse me. Now, if we were to look at these graphically, we're taking a look at two lines, and we're looking where they intersect. So right here would be our answer. So that would be one possibility. We have a single point as our answer. Now I could have one line like this, and I could have one line like this, where there's no answers. There's no solution. And I could have one line like that, and then I could drop the second line right on top of it, in which case it would have infinite solutions. So infinite answers. So those are our three possibilities. Now these first problems are just asking us to determine whether the given ordered pair is a solution of the system. So let's take a look at that. We've got -2, 3. And we've got 5x plus 4y is equal to 2. We've got 7x minus y is equal to -17. I wonder if that's a solution. So what we're going to do is we're going to plug for x we'll plug in -2, and for y we'll plug in 3. So we got 5 times -2 plus 4 times 3, and this equals here is a question mark. We're wondering if that's equal to 2. Excuse me. Well, 5 times -2 is -10, plus 4 times 3 is 12. And again, this is a question mark at this point. -10 plus 12 gives us 2. So 2 does equal to 2. So the answer here for this part will be yes. Now let's check this other part. So plug -2 in for the x, minus 3 in for the y. And again, we're checking to see if that's equal to -17. Well, 7 times -2 is -14, minus 3. That's a question mark. Well, -14, -3 is -17. So you see they're both equal to each other. -17 is equal to -17. So the answer to this one is yes. And since they're both yes, then this is a solution. So that is a solution. Now, if one of them had been no, then we wouldn't have had a solution. Let's look at the next one. We got 1, 5. And we're wondering about 8x minus 2y is equal to -2. And we're also wondering about 7x plus 3y is equal to 10. Okay, so we're going to plug this in for x and plug this in for y. So we got 8 times 1 minus 2 times 5. And this is a question mark. We're wondering if that's equal to -2. Well, 8 minus 10. 8 minus 10 gives us -2, so we got -2 equals -2, so this one is yes, that is a solution. Well, let's plug into this other one. So put 1 in for x, and we'll put 5 in for y. And we're wondering if that's equal to 10. So we got 7 plus 15, question mark. 7 plus 15 is, what was that, 22? This one is no. So since one of them is no, this is not a solution. So 1, 5, it does not work in both of these. Works in one of them, but not in the other. So it has to work in both of them for it to be a solution. Let's start a new page here. And it says solve this by the substitution method. So I got 5x minus 4y equals 30. Y equals to 2x minus 9. And it says solve it using the substitution method. Well, step 1. Solve one of the equations for one of the variables. Doesn't matter which one you pick. I'm going to pick the second equation because it's already solved for y. So pick the second equation, it's already solved for y. So we're basically done in step 1. Now step 2. Plug this into the other equation. And solve. So plug this into the other equation and solve. Well, we got 5x minus 4y equals 30. And we just said y is equal to 2x minus 9. So we're going to replace the y in this equation with 2x minus 9. So we got 5x minus 4 times 2x minus 9 equals 30. Well, negative 4 times 2x gives us negative 8x. Negative 4 times negative 9 is 36. Equals 30. 5x minus 8x gives us negative 3x. Plus 36 equals 30. Take the 36 over to the right side. So we got 30 minus 36. 30 minus 36 is negative 6, and then divide both sides by negative 3. And we get x is equal to 2. Well, step 3. Plug this value into the equation from step 1 and solve. Now the equation from step 1 will always be solved for the other variables, so it's a perfect one to plug it into. So we're going to plug that into y is equal to 2x minus 9. And we just said that x is equal to 2 up here. So we're going to replace the x with 2. So we got y is equal to 2 times 2 minus 9. Y is equal to 4 minus 9, or y is equal to negative 5. So our answer, we write it in point form. We said x was 2, and we said y was negative 5. So our answer is 2, negative 5. Now I'm going to do this problem again using the calculator to show you how you can solve that with the calculator. There's a couple different ways you can do it with the calculator. I'm going to use matrices, even though this is a little bit before we actually cover matrices. Now, solving a system of equations using the T83 84. First step, get all the terms, with x's and y's on the left side, numbers on the right side. Step 2, write down your matrix. So write down your matrix. And basically, you drop the x's, the y's, and the equals. And we'll see that some more. Step 3. Input your matrix. And some of these steps aren't very detail oriented, and we'll see why. And we want to make sure we do a second mode once we're done inputting our matrix. And let's try this, step number 4. Now, after we do a second mode, we've exited out. So we want to go back into our matrix menu. So go into matrix menu. We want to right arrow. And then we want to up arrow to RREF. Stands for reduced row echelon form. We want to enter. Go into the matrix menu. And enter on A. And then enter again. And go over here to step 5. If decimals. So if decimals, then you do math enter. So math enter. Let's see what in the world I'm referring to here. Let's do this problem again using these steps. So we got problem number 3. We got 5x minus 4y equals 30. And we got y is equal to 2x minus 9. Okay, step 1. Get all the terms with x's and y's on the left side and numbers on the right side. Well, the first equation is good as is. Now in this one, I'm going to take 2x over to the left side. So that gives us negative 2x plus y equals negative 9. Now specifically, we want to line up the x's, line up the y's, and then we have our numbers on the right side. Now step 2 says write down your matrix. Now matrix is a rectangular array of numbers. And that says drop your x's, drop your y's, and your equals. So we're going to have 5, negative 4, 30. We'll have negative 2, 1, and negative 9. Now the size of this matrix is rows by columns. So it's rows by columns, which means we'll have 2 rows and we'll have 3 columns. So it's a 2 by 3. Okay, input your matrix. Let's go take a look at how to do that. If you got a T83 plus, T84 plus, so forth, you're going to find your matrix menu underneath see the x and negative 1? That's our inverse button actually, but see the x and negative 1? The matrix is above that. So to get in your matrix menu, you do second x and negative 1. Now if you got just a T83, not a T83, but a T83, the plus is different. Plus is like this. Then you'll actually have a button that says matrix. So it's a little easier to get into it. But anyway, you want to get into it. Now we're going to input our matrix. We have to go over to the edit menu for that. So we're going to right arrow twice to go over to the edit. And I want to do enter on A. We're going to put it into A. So I just go ahead and press enter. Now I have numbers in mind. You may not have numbers. Don't worry about how to clean them out, or if you don't have them, don't worry about that. First thing it asks us for is the size of the matrix. We said this is going to be a 2 by 3. So you do 2 inner and 3 inner. Now we want to put our numbers in. So we got 5, negative 4, 30. So do 5 inner, negative 4 inner, 30 inner. After you type in each number and press enter, it saves it and goes to the next cell. And then negative 2 inner, 1 inner, and negative 9 inner. Now after you get those in, you want to double check to make sure you didn't type any in wrong. Notice how I put second mode here. A lot of people forget to do that. You have to do a second mode to quit. So do second mode, exit out. And now we're ready for step 4. Go into the matrix menu. On my calculator, it's second x to negative 1. It says do a right arrow. So we're going to right arrow one time to math. And then it says up arrow to RREF. Make sure you choose the one with 2 R's. So I'm going to do an up arrow and choose the RREF. Press enter on it. And then go into the matrix menu again. So we'll do second x to negative 1. Now I say do enter on A. You notice how A is already highlighted under names? We just press enter. And then you say I have another enter. Now what RREF will look like is your first square here will be a diagonal of 1, 0s everywhere else. Your far right column will be your answers. This will be X and this will be Y. So our answer to this is going to be 2, negative 5. And that should be the same thing we found up above. 2, negative 5. So that'd be that particular problem. Let's take a look at another one. And I'm going to do it both ways. I'll do it via substitution and I'll do it via the calculator. Substitution is handy to know because the next section, or not next section, but later on in this chapter, you run across problems that you have to do the substitution. You can't plug them into your calculator. Okay, and we're going to solve this as by substitution. Well, substitution. We pick one of the variables, or one of the equations to work with, and we solve for one of the variables. It doesn't matter which one. I'll pick the second equation. So I got negative x plus 2y is equal to negative 9. So we want to solve one of the equations for one of the variables. Probably the easiest one to solve for here is x. So I'm going to take the negative x to the right side, and I'll take negative 9 to the left side. So we got 2y plus 9 is equal to x. Step 2. We want to plug that into the other equation. So where the x is in this other equation, we're going to put in 2y plus 9. So we got 3 times 2y plus 9 plus 8y is equal to 13. And we want to solve it. 3 times 2y gives us 6y. 3 times 9 is 27. Plus 8y equals 13. Combine together like terms in any step. Here we got 6y plus 8y. That gives us 14y. Plus 27 equals 13. Take 27 to the right side and it becomes a negative 27. And we got 14y is equal to negative 14. Well, divide both sides by 14. And we get y is equal to negative 1. Now step 3. Plug this into the equation from step 1. See, step 1 we said x is equal to 2y plus 9. So x is equal to 2y plus 9. Now the beauty of choosing the equation from step 1 is already solved for the other variable. So we'll put negative 1 in for y. So we've got x is equal to 2 times negative 1 plus 9 which is negative 2 plus 9, which gives us 7. So our answer will be 7, negative 1. Just do this via the calculator. Okay, so first step is to get all of our terms with x's and y's on the left side, numbers on the right side. That's done. Then we want to write down the matrix, drop the x's, drop the y's, and equals, and keep the numbers in their signs. So we got 3, 8, 13, negative 1, 2, negative 9. The size of this matrix, rows by column, is 2 by 3. So let's go ahead and put this in. So I'm going to go to my matrix menu. Again, second, x and negative 1. Then I want to right arrow over to edit. I'll do enter on A. You might as well put it in A. There's no benefit putting it anywhere else. It asks for a size of our matrix. So I'll do 2 for rows, enter. 3 for columns, enter. And we want to type these numbers in. So I got 3, enter, 8, enter, 13, enter, negative 1, enter, 2, enter, and negative 9, enter. Double checking my numbers. Make sure you exit out before you do the next step. So do second mode. Now we're going to go back into our matrix menu. So I do second, x and negative 1. We'll right arrow to math. We'll up arrow to RREF. Press enter on it. We'll go back into our matrix menu, second, x and negative 1. We'll do enter on A, and we do enter again. And again, our far right column is our answers. Now this has to be a diagonal 1, 0 everywhere else, which it is. So 7, negative 1 is our answer. Which I believe is what we got over here. 7, negative 1. So let me start a new page, and we'll look at the next problem. So we've got y is equal to negative 1/4 x minus 3, and y is equal to negative 5/2 x plus 7. And we'll first do it via substitution. We're going to solve one of the equations for one of the variables. Doesn't matter which one. I'll pick the first one. Now this is already solved for y, so that's in a perfect form. We don't have to do anything on step 1. Now step 2 says plug that into your other equation. Our other equation is y is equal to negative 5/2 x plus 7. Now, step 1, we have y is equal to that, so where the y is here, we're going to plug in negative 1/4 x minus 3. And that negative 5/2 x plus 7 carries down. And now we want to solve this. Well, first step in solving is always get rid of your fraction. Have to get rid of parentheses. But we'll multiply everything by the LCM of all our denominators. We got 4 and 2, so our LCM would be 4. So multiply times the negative 1/4 x times the negative 3 times the negative 5/2 x and times 7. Well, this 4's a cancel. 2 and 4 are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So we got negative 1x minus 12 equals negative 10x plus 28. Get everything with an x on one side, so I take negative 10x over there. Numbers on the other side, so I take negative 12 over there. So we've got negative 1x plus 10x equals 28 plus 12. Well, negative 1x plus 10x gives us 9x. 28 plus 12 gives us 40. Then divide both sides by 9. these 9's cancel. And we got x is equal to 40 over 9. Well, remember our third step. We now want to plug that back into the equation in step 1. Step 1 is y equals negative 1/4 x. Minus 3. Okay, so we just said x was 40 over 9, so we'll plug that in for x. So we got 40 over 9. Now 4 and 40 both divisible by 4. 4 divided by 4 is 1. 40 divided by 4 is 10. So we get negative 10/9 minus 3. Now this is a mixed number. So we can take the negative 3 times a 9 gives us negative 27, plus the negative 10 gives us negative 37 over 9. Again, I multiplied negative 3 times 9, gives us negative 27, plus the negative 10 gives us negative 37. So our answer will be 40 over 9 and negative 37 over 9. Let's do this on a calculator. And I'm going to have to open my window. I'm dying here. There. Gets hot in my little room. Okay, let's do this via the TI3, TI4 calculator. Now you have to have all the variables on one side and numbers on the other. So I'll take negative 1/4 x over. So it becomes positive 1/4 x plus y equals negative 3. And I'll take negative 5/2 x over. And we get positive 5/2 x plus y is equal to 7. Now when we write down our matrix, we want to drop the x's, y's, and equals. So we've got 1/4, 1, negative 3, 5/2, 1, and 7. Now the calculator doesn't care that they're fractions. It handles it just fine, in case you're wondering. So let's go to our calculator and enter this in. So we're going to go into second, x and negative 1 to get in our matrix. Again, if you have a TA3, you have a matrix button. I'm going to right arrow over to edit, do enter on A. It's a 2 by 3 again, so I do 2 enter, 3 enter. And we got 1/4, so I do 1 divided by 4, enter. Then 1, enter, negative 3, enter. Then we got 5/2, so do 5 divided by 2. And then 1, enter, and 7, enter. Now notice it changed those to decimal, but that's fine. It still keeps all the decimal places necessary. I'm going to do a second mode to exit out. Then we'll go back into our matrix menu. So I do second, x and negative 1. Right arrow to math. Up arrow to RREF. Enter on it. Then go back into my matrix menu. Second, x and negative 1. Enter on A. And enter again. Now notice our first square is a diagonal of 1, 0, 0, everywhere else. That's what it has to be. If it isn't, it could be one of our oddball cases. But we have decimals over here. We don't want decimals. But remember my last step was said if you had decimals, do a math, enter, enter. And our answer is 40 over 9 and negative 37 over 9. Even if you're not in my class and your particular instructor doesn't want you to do it by hand, this is a fantastic way to double check your work. See if you made a math error somewhere, because it's very easy to make math errors in these problems. Yeah, let me bring up another tablet, and we'll look at the next problem. This says solve each system by the addition method. Some books actually call this the elimination method. Let's take a look at it. We got 5x plus 4y equals negative 13. 2x minus 4y is equal to 6. With the addition method, with the elimination method, what we do is we add together the two equations. Now the like terms have to be in the same columns. See how the x's are together, the y's together, and numbers are together. Now 5x plus 2x gives us 7x. 4y minus 4y, that actually drops away. And negative 13 plus 6 gives us negative 7. Now notice what we have left now is 7x is equal to negative 7. Well, we can solve this for x. So we'll divide both sides by 7. And we get x is equal to negative 1. Now we want to take this and plug it into one of our equations and find our y value. It doesn't matter which one you pick. I'll pick the second one. I think it looks a little easier. So I got 2x minus 4y equal to 6. And we just said that x is equal to negative 1. So put negative 1 in for the x. So we got 2 times negative 1 is negative 2 minus 4y equals 6. Take negative 2 to the right side. Take anything across your equals, your sign changes. So it becomes a positive 2. Six plus 2 gives us 8. Divide both sides by number in front of your y, which is a negative 4. And we get y is equal to negative 2. So x is negative 1, and y is equal to negative 2. And that would be our answer, using the addition method. Let's show this on the calculator. Well, we're going to, we got all everything with an x and y on the left side, numbers on the right side, so that's good already. We're going to write down a matrix goes along with that. And again, we'll drop the x's, drop the y's, and drop your equals. So I have 5, 4, negative 13, and 2, negative 4, and 6. Let's go input this into our calculator. So we'll do second, x and negative 1. We're going to right arrow over to edit, do enter on A. Size of our matrix is 2 by 3, so I do 2 enter, 3 enter. And we got 5 enter, 4 enter, negative 13 enter. 2 enter, negative 4 enter, and 6 enter. So we'll do exit out, do a second mode, and now we'll go through our steps. So we'll do second, x and negative 1, go back to the matrix menu, right arrow over to the math, up arrow to RREF. And do enter on that. Go back in my matrix menu, do enter on A, and enter again. Now again, our first square should be a diagonal of 1, 0 everywhere else, which it is. And our far right column is our answers. So x is equal to negative 1, and y is equal to negative 2. Now the order of your answers corresponds to the order of your variables when you input them. See how the x column was first and the y column was second when I input it? The x is first and y is second. So that's how you figure out what's what. And let me double check my work over here to see if I came up with the same answer. I did. Let's look at the next problem. Got negative 3x minus 2y equals negative 8. And we got 5x plus y equals 18. And we want to solve it using the addition method. Now if I add these together, negative 3x plus 5x is 2x, negative 2y plus y is negative y. None of my variables disappear. And that's what you're trying to achieve. You're trying to get either the x's or y's to disappear. Well, take a look at our y's. Here we have negative 2y. If this was a positive 2y here, then they would cancel each other out. So I need a 2 here, so I'm going to multiply the second equation by 2. First equation remains as is. Now multiply the 5x times 2, that gives us 10x. the y times 2, that gives us a positive 2y, and the 18 times 2, which gives us 36. And now we want to add these together. Negative 3x plus 10x gives us 7x. Negative 2y plus 2y drops away. Negative 8 plus 36 gives us 28. And we're now left with 7x is equal to 28. Divide both sides by 7. And we get x is equal to 4. Well, we wanted to plug that into one of our equations so we can solve for y. It doesn't matter which one. I'm going to pick this one. 5x plus y equals 18. That looks a little easier. So we just said that x was 4. So I got 5 times 4 plus y equals 18. 5 times 4 is 20. So we got 20 plus y equals 18. Take 20 to the right side, and we got 18 minus 20, or y is equal to negative 2. So our answer is 4, negative 2. Well, let's do this via the calculator. Now everything with an x and y is on the left side, numbers on the right side, so that's already in perfect form. We're going to drop our x's, y's, and equals, and just keep the numbers in their signs. So I got negative 3, negative 2, negative 8. 5, 1, and 18. So let's go ahead and put this in. So I'm going to do my second x and negative 1, and then right arrow over to edit. Enter on A, it's 2 by 3 again, so we do 2 enter, 3 enter. We'll input our numbers, so I got negative 3, negative 2, and I'm pressing enter after each number. Negative 8, enter. 5, enter. 1, enter. 18, enter. Now I exit out, so I do second mode. Now I go into my matrix menu again, so I do second x and negative 1. Right arrow to math. Up arrow to RREF. Press enter on it. Go back in my matrix menu. Do enter on A. And enter again. And again, we should get a diagonal of 1s and 0s everywhere else in the first square, which we do. And our right column is our answers. So 4, negative 2. So this is x and this is y. And let me double check it against what I got. 4, negative 2. Let's look at our next problem. Okay, so stupid train. I swear they must do it louder at night, which makes sense, I guess, as you can't see. Get everything written down. Now I'm going to work at eliminating the y's. And obviously if I add these together, 5x plus 3x is 8x, negative 3y plus 2y is negative y. Nothing cancels away. Now sometimes you have to multiply both equations by a number. So to get rid of the y's, for like the negative 3y here, I'm going to multiply it times the other number, which is 2. And for the 2y here, I'm going to multiply it by the other number, which is 3. Now this is already in a perfect form where one of them is negative and one of them is positive, so I don't have to worry about signs. But if they were both the same sign, both positive, both negative, I'd have to change the sign of one of these. So I'll multiply everything in the first equation by 2. So we got 10x minus 6y equals 34. Multiplying everything by 2. Second equation, we multiply everything by 3. 3 times 3x is 9x. 3 times 2y is 6y. And 3 times 14 gives us 42? Yeah. Okay, so now I'm going to add them. Hopefully one of my variables will be eliminated. If it isn't, that means you didn't multiply these by the right numbers. Well, 10x plus 9x gives us 19x. Negative 6y plus 6y drops away. 34 plus 42 gives us 72. No, 76. And now we got 19x is equal to 76. And I'm going to divide both sides by 19. And those cancel. And I think it's 4. Yeah, 4. Okay, now we want to plug that into one of our equations and solve for y. I'm going to pick the second one here. 3x plus 2y equals 14. So 3x plus 2y equals 14. And we just said x is equal to 4. So I got 3 times 4 plus 2y equals 14. 3 times 4 is 12 plus 2y equals 14. Take the 12 over. So we got 2y is equal to 14 minus 12. Or 2y is equal to 2. Divide both sides by 2. And we get y is equal to 1. So we already said x is 4. So our answer will be 4, 1. Well, again, let's plug this into our calculator. My ear is getting really sore. I'm going to try to take my glasses off. Probably means I won't be able to see a thing. Okay, our x's and y's are all on the left side, numbers on the right, so that's perfect form. So we'll drop our x's and our y's and our equals. So we got 5, negative 3, 17, 3, 2, and 14. So 2 by 3 again. All of them in this section are 2 by 3. So let's go ahead and put the matrix. So we'll do second, x and negative 1. Right arrow over to edit. Enter on A. Now since these already have the numbers here, all you have to do is press enter, enter. And let's put in 5, negative 3, 17. Pressing enter after each one. And then 3, 2, and 14. Again, pressing enter after each one. I'll do a second mode to exit out. And we'll go through our steps. Second, x and negative 1. Right arrow to math, up arrow to RREF. Enter on it. Go back on my matrix menu. Do enter on A, and enter again. And again, we should get a diagonal of 1, 0, 0 everywhere else in our first square, our first 2 by 2 square. And the far right column is our answers. So it'd be 4, 1. Which is, I think, what we came up with by hand. Yeah, it is. Let me bring up another tablet, and we'll look at the next problem. So solve each system by the addition method. So we got negative 7x is equal to 3y minus 20. And we got 4y equals 18 minus 5x. Besides, for your calculator, if you're using the addition method, the elimination method, you have to have all the variables, all the terms of variables on one side, numbers on the other. So, I'm going to take the 3y and move it to the left side. So we got negative 7x minus 3y equals negative 20. And I'll take the negative 5x and move it to the left side. So we got positive 5x plus 4y equals 18. Okay. Now I'm just going to eliminate the y's again. This one's already negative, this one's positive, so that's perfect. For this negative 3y, I want to multiply it by 4, the other number. For the 4y, I want to multiply it by 3, the other number. So negative 7x times 4 is negative 28x. Negative 3y times 4 is negative 12y. Negative 20 times 4 is negative 80. And we'll multiply everything in our second equation by 3. So 5x times 3 is 15x. 4y times 3 is 12y. And 18 times 3 gives us 54? Yeah, 54. You know you picked the right numbers if one of your variables gets eliminated. Now I tend to pick x's or y's quite a bit, but you can pick any. You could eliminate the x's if you wanted. Well, negative 28x plus 15x gives us negative 13x. Negative 12y plus 12y. Never go to bed. Cancels away. Negative 80 plus 54 is negative 26. Well, now we're going to divide both sides by negative 13. And we get x is equal to 2. Well, now we need to find out what our y is. And probably the second equation is the easiest one to plug it into. The 4y equals 18 minus 5x. So I've got 4y is equal to 18 minus 5x. And we'll plug the 2 in for the x. So we've got 4y equals 18 minus 5 times 2. And minus 5 times 2 is 10. So 18 minus 10 gives us 8. And divide both sides by 4. And we get y is equal to 2. So our answer will be 2, 2. Now let's do it on the calculator. Now the one we'll best work with for our calculator is when all the x's and y's are on the left side and numbers on the right. So this one right here. So again, we'll drop the x's, y's, and equals. So we've got negative 7, negative 3, and negative 20. And I got 5, 4, and 18. So let's go put this in. So do second, x and negative 1. Right arrow over to edit. Enter on A. 2 by 3 again, so I'll just do enter, enter. And we got negative 7, enter, negative 3, enter, negative 20, enter. Then 5, enter, 4, enter, and 18, enter. Want to make sure you exit out, so do second mode, and then we'll go through our steps. So do second, x and negative 1, right arrow to math, up arrow to RREF, enter, go back in the matrix menu, do enter on A, and enter again. And our answer is the far right column, which would be 2, 2. Let's start a new page, and let's look at the next problem. Okay, so this one we got 8x plus 4y equals 3, and y is equal to negative 2x plus 5. Now it says solve by the method of your choice. Identify systems with no solution and systems with infinitely many solutions, using set notation to express your solution sets. I'm going to use the substitution for this one. The reason why is because this one's already solved for y, so that works out perfect with that. So again, substitution, our first step is to pick one of your equations and solve for one of the variables. Well, this one's already solved for y, so that one's done. Step 2, we're going to substitute that into the other equation. So we got 8x plus 4y equals 3. We just said y is equal to negative 2x plus 5, so where this y is, I'm going to put in negative 2x plus 5. So we got 8x plus 4 times negative 2x plus 5 equals to 3. 4 times negative 2x is negative 8x. 4 times 5 is 20 equals 3. Combine together like terms in any step. 8x minus 8x cancels. And you're left with 20 is equal to 3. Well, that's no good. We were solving for x, but our x disappeared completely. Well, the question is, when is 20 equal to 3? Well, it's never. This is a no solution. There's no values of x and y that cause these to be true. Well, let's look at it on the calculator and see what it looks like. So I got 8x plus 4y equals 3. We want to get all the x's and y's on the left side and numbers on the right. So on this one, I'm going to take the negative 2x over. And we've got a positive 2x plus y equals 5. Again, you want to line up the like terms. X's in the same column, y's are in the same column, and our numbers are on the other side of the equals. Well, let's start down our matrix. We got 8, 4, 3, 2, 1, 5. So I'll go to my matrix menu. So, okay, I'll do second, x to negative 1. Right arrow over to edit. Enter on A. 2 by 3, so I just do enter on 2 and enter on the 3. We got 8, 4, 3. 8, enter, 4, enter, 3, enter. 2, enter, 1, enter, 5, enter. Exit out, do a second mode. We're going to go back in our matrix menu, second x to negative 1. Right arrow to math. Up arrow to RREF. Enter on it. Go back in our matrix menu, do enter on A, and enter again. Now we got a decimal, but we know how to handle that. We'll press math, enter, enter to change it to fraction. And what it gave us was 1, 1/2, 0, 0, 0, 1. Now if I look at my first square, my first 2 by 2, since I got 2 equations, 2 variables, I look at the first 2 by 2. Obviously I don't have a diagonal of 1, 0, everywhere else, so this is one of the oddball cases. Now if your last row is all zeros and a single 1, that means no solution. Empty set if you want to write it that way. But again, if your last row is all zeros and a single 1, then that always means no solution for that oddball case. Well, let's look at the next problem. Maybe. Oh yeah, it did change. Okay. So we got 8x plus 2y equals 6. And y is equal to negative 4x plus 3. Solve the method of your choice. Since I did the last one as substitution, I'm going to do this one as addition or elimination method. Well, I'm going to get all the x's and y's on one side. So I'll take negative 4x over the left side. So we've got 8x plus 2y equals 6. And that would give us 4x plus y is equal to 3. Again, you take anything across or equals, your sign changes. Now I'm going to eliminate the y's. This one is a positive 2y. I would need this other one to be a negative 2y. So I'm going to multiply my second equation by negative 2. So I got 8x plus 2y equals 6. Negative 2 times 4x is negative 8x. Negative 2 times y is negative 2y. And negative 2 times 3 gives you negative 6. Well, let's add these together. 8x minus 8x drops away. 2y minus 2y is 0. And 6 minus 6 is 0. That's no good. We were solving our equation, and all of our variables disappeared. We got 0 is equal to 0. If you get something that's always true, like 0 equals 0, 1 equals 1, so forth, what that means is this is infinite solutions. And that's what we'd write down. I think that's all they're wanting for this section. It says systems with infinitely many solutions. Now they said put it in set notation, but I'm not going to worry about that. Well, let's take a look at this on the calculator. Now again, you have to have all the x's and y's on one side and numbers on the other for your calculator. So that's a perfect form. So from our matrix, we'll drop the x's, y's, and equals. And we've got 8, 2, 6, 4, 1, 3. And let's see what this looks like when we plug it in. So I'm going to go to matrix menu, second x negative 1, right arrow over to edit, enter on A, enter on 2, enter on 3, and I got 8, enter, 2, enter, 6, enter, and then 4, enter, 1, enter, and 3, enter. And I want to exit out, go back in my matrix menu, second x and negative 1, right arrow to math, up arrow to RREF, enter on it, go back in my matrix menu, second x and negative 1, enter on A, enter again. We got decimals, but we know how to handle those. Math, enter, enter. And look what we got. We got 1, 1/4, 3/4, and 0, 0, 0. Now it's two equations, two variables. So if we look at our first 2 by 2, we don't have our diagonal ones, zeros everywhere else, which means it's one of our oddball cases. It's either no solution or infinite solutions. Now notice our last row is all zeros. Well, this means infinite solutions. So if your last row is all zeros, it's infinite solutions. Now, later on, not in this section, but when we get more into the matrices, we'll actually see another way of writing infinite solutions down. And tablet blew up again, so let me bring up a fresh one. There we go. And let's take a look at our last problem here. We got 12, and we got x over 3 minus 1/2 equals y over 3, and 4x minus y is equal to 8. Now for this particular problem, I'm just wanting to show that you don't want to work with fractions, no matter what method you're working with. So if you got a fraction, the first thing you want to do is get rid of them. So for my first equation here, I'm going to multiply everything by the LCM of all my denominators. I got 3, 2, and 3, and the 3's repeat, so I'm just looking at 3 and 2. So I'm going to multiply everything by 6. So my first equation, I got 6 times x over 3 minus 6 times 1/2 equals 6 times y over 3. Well, the 3 and 6 both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 2 and 6 both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And 3 and 6 both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So this becomes 2x minus 3 equals 2y. Now, I want to get this in the right form. I want to get all my x's and y's on one side, numbers on the other. So I'll take 2y over to the left side and negative 3 to the right. So we get 2x minus 2y equals positive 3. Again, you take anything over the other side, the sign changes. So now our first equation looks like this. 2x minus 2y equals 3. And second equation is still 4x minus y equals 8. I'm going to do this with addition. I'm not going to plug any more in the calculator. I think you got that. Now I'm going to eliminate the y's. This is a negative 2y, so I want this to be a positive 2y. So I'm going to multiply this second equation by negative 2. First equation remains as is. Multiply this by negative 2, I get negative 2 times 4x is negative 8x. Negative 2 times negative y is a positive 2y. And negative 2 times 8 is negative 16. Now maybe, since this comes up with fractions, maybe it wouldn't be bad to check it on the calculator. I may do that anyway. Okay, now we're going to add these. 2x and negative 8x gives us negative 6x. Negative 2y plus 2y drops away. 3 minus 16 is negative 13. And then we'll divide both sides by -6, and we got -13 over -6, or x is equal to 13/6. Now I want to plug it into my second equation. That looks a little easier. 4x minus y equals 8. We just said x was 13/6, so I got 4 times 13/6 minus y equals 8. 4 and 6 both of us by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. So we got 2 times 13, 26 over 3. I'll take the negative y to the right side and the 8 over. So we got -8 equals y. Now this is a mixed number. I can take the -8 times 3 is -24 plus 26 gives us 2/3. Denominator stays the same. So assuming I did this right, we would have x is equal to 13/6 and y is equal to 2/3. Let's go double check it on the calculator. Now again, when I want to plug in, I could do this one here for that matter. But this one's already in a perfect form. So let me play with that. Actually, I guess that's not saying I didn't make a math error here, did I? So I guess I'll work with that then. Now again, I have to have all the x's and y's on one side, so I'm going to take the y over 3 over the left side and -1/2 to the right side. Now this becomes 1/3 x, that's the x over 3. Now the y over 3 becomes a -y over 3 or a -1/3 y. And the -1/2 is a +1/2. And then we got 4x minus y equals 8. And let's write down our matrix. We're going to drop the x's, y's, and equals. So we've got 1/3, -1/3, 1/2, 4, -1, and 8. So let's go put this in and see what we get. So go to my matrix menu, go over to edit, enter that in. So I got 1/3, enter, -1/3, enter, 1/2, enter, 4, enter, -1, enter, and 8, enter. Exit out, go back to my matrix menu, right arrow over to math, up arrow to RREF, enter. Go back to the matrix menu, do enter on A, and enter again. Now we get decimals, but we know how to handle those. I'll do math, enter. And 13/6 and 2/3. And I'm glad to see that it matched. Again, nothing else. It's a fantastic way to check your answers. And that's the last problem. So let me stop the recording.